Alrighty, boys and girls, welcome to our third video lesson in Unit 1. Unit 1 on inequalities. Section 3, we're doing a video on absolute value inequalities. Okay, solving absolute value inequalities. These are the steps that I do. And again, they're a little bit different from some of the other people, but that's fine. We're going to go through them right here. Our first step is to solve for the absolute value. Once you've done that, pretend it was an equation. So just ignore the fact that it's an inequality, pretend it says equals, and solve for x. Once you get x, we're going to get 2 points. Those are going to be what we call our critical points. And then your answer is going to be one of two things. It's either going to be a segment in between the two critical points. It's like an and. It's like an and compound inequality. It's like an and. Okay? Or we're going to get an answer in red here, where we're going to have two rays going away from each other with a missing section in between. It's like an or inequality. It's like an or. So if you want to memorize, what you need to do is think about it this way. Okay, if the absolute value, whatever it is, so it could be something inside of there, but let's call it x, if that is less than or equal to our number, then it's the segment right here. It's like the and. Or in red now, if the absolute value, whatever it is greater than or equal to, right? Could be greater than or equal to the expression. Then we have the or inequality rays going away. So looking right here, the absolute value of x is less than 5. First thing we're going to do is we're going to solve this. We're going to pretend that this was an equation. So absolute value of x is equal to 5. So we now know our critical points is 5 or neg 5. 5 and neg 5, I should say. So I'm going to put in a point right here at 5, a point right here at neg 5. And because I'm dealing with less than, I'm going to have open dots as opposed to closed dots if it were less than and equal to. So I have open dots. And now we just got to decide. Am I in between? So in other words, am I going to be a segment in between like this? Or am I going to be two rays going apart from each other like this? It's going to be one or the other. All we're going to do is we're going to throw in any point that's not a critical point. Let's, for example, let's choose the point x equals 1. That's a nice one. The easiest one is actually x equals 0. But let's try x equals 1. If I throw in x equals 1 right here, the absolute value of 1 is 1. Is 1 less than 5? Yes, it is. So I already know my answer is going to be in between. But I could have chosen any point. Like, for example, I could have chosen x equals neg 3. If I throw in x equals neg 3 into here, I get the absolute value of negative 3 is 3. 3 is less than 5, so 3 also worked, in between. If I had thrown in a point outside of my 2 points, outside of my critical values, like for example 6, if I had thrown in 6, the absolute value of 6 is 6. 6 is not less than 5, so therefore 6 didn't work, so that's not part of my solution. So my graph looks like this. We can write our answer as negative 5 is less than x is less than 5. There's my compound inequality. I can also write x is greater than neg 5 and x is less than 5, but of course I like this way better. Just easier to write. And in interval notation, I'm going to write negative 5, comma 5, and these are both going to be parentheses because we do not include those points at neg 5 and 5. So as we look at this guy right here, and we now have the absolute value of x is greater than or equal to 5, so we're going to pretend this was an equation. Absolute value of x is equal to 5. We've already solved for the absolute value, so of course x equals neg 5 or 5. Those are our critical points. We're going to put them right here at neg 5 and again here at 5. We choose a point to plug in. Let's plug in 0. plug in 0 for x, so I get absolute value of 0, which of course is 0. 0 is greater than or equal to 5? No! 0 is not greater than or equal to 5, so therefore 0 right here did not work. This whole section in between does not work, which means that the sections outside that section must work. So our answer and on the graph is going to be a closed dot at negative 5 and everything less than that. Closed dot at 5 and everything greater than that. Okay, 0 did not work. 0 right here did not work. So this section right here is not part of our answer. Everything outside is. So we can write this now as x is less than or equal to negative 5. Or, this is an or, x is greater than or equal to positive 5. In interval notation, that's going to be from negative infinity to negative 5, bracket, parentheses, union, bracket, 5, comma, infinity, close that off with a parenthesis.